We are starting with the topic of hydrocarbons. And this chapter is going to be a very, very long chapter. So we are going to be doing it 2 times separately. From the other part of the syllabus, we are going to focus on this hydrocarbon. And I have a particular slide, as you can see, which will be explaining that in details and also make us, it will actually increase our pace because it will be kind of a thing that will make us understand it better, like I said. So looking at this, at first, we are going to start with the definition of hydrocarbon. And as you can see, then we have hydrocarbons. Now, definition we give to this, so we have hydrocarbon that defined for their compounds, which contains only carbon and hydrogen atoms. So in the other words, you can say hydrocarbons are just compounds with hydrogen and carbon only. So it's very simple. Hydrogen and carbon come together to give hydrocarbon. I hope you understand this. So in continuation to that, we can talk about the branches and the way we actually group hydrocarbons. So to see that, we say hydrocarbon are being grouped into different branches. The first set is, as you can see, we have aliphatic, and the other types is popular, which we call aromatic. Now, the word aromatic simply means it contains one or more benzene. Now, about this aliphatic, they can also be grouped into 3 different types, which are the first one, you can see, first group are called the alkanes. The alkanes generally are said to be saturated. The meaning of saturated simply means they contain single bond, or again, all the hydrogen satisfied with the carbon. Because we have studied carbon compounds where we say carbons are tetravalent. So in continuation to this, we have another example of aliphatic, which is the alkanes. And when you talk about alkanes, before that, other example of alkanes are given. Cycloalkanes can also be saturated, and they are going to have something like a ring form, which we are going to talk extensively. And the only thing in them is that the ring structure is still what a single bond. Now the next one, which is another example of aliphatic hydrocarbon, is basically the alkanes. And about the alkanes, they are unsaturated. And because that they have double bond in them, this is what makes them unsaturated. That means the hydrogen is not what's saturating the carbon, which we are going to talk in details as we move on in the chapter. So the next type of aliphatic hydrocarbon, they can also exist as cycloalkanes. And what makes them different from cycloalkane is the presence of the double bond. Excuse me, as you can see here, whereas these are single bond. The next type is the alkynes. The alkynes are characterized by 3 bonds that exist between their carbon-carbon chains, and they can also exist the same way we have this as what cycle. So now, for us to understand very well, we are going to look into saturated hydrocarbon. And what do we call saturated hydrocarbon? Then the definition we give to saturated hydrocarbon are just those ones that are, one is that they are single bond. Let's be taking it one by one so that we have the notes. Apart from that, in single bond, you can see this rotational structure I'm trying to show you. This is the way they have when we look at them in 3D view. So this is the way they exist. The center atom is carbon, and the hydrogen are attached to them. So we can calculate the bond angle. We can calculate the hybridization. In fact, generally, we say they are what's like sp3 hybridized. Under our physical chemistry, we have talked about how to calculate the hybridization of organic compounds and inorganic compounds. So one of the characteristics of saturated hydrocarbon is that they have single bond. They have bond angle of about 109.23. And again, you can see they are sp3 hybridized, and the carbon is sufficient. But in the hydrogen is what is sufficient for each of the carbon atoms. So we can have that they are connected by carbon-carbon chain, which is single bond, Another example is examples of them as stated before is we have the alkanes and the cycloalkanes. Cycloalkanes are the main form which we are still going to talk about extensively. For you to get what I'm talking about, we can just give an illustration. So you can see if I have something like this. And see this is a ring form where I have C, carbon, carbon, and carbon. In this type, this is different from C, C, and C. So this is like a cycloform. This is like a switch form. So another characteristic is that they contain the maximum number of hydrogen atoms that the carbon compound can possess. Like I said, we've talked about that carbon is tetravalent. That is, they actually have 4 valence electrons, and because of 4 valency, they need 4 more, which they satisfy from what you can see here. Another illustration is if there are more than 2, you can see the first carbon and the second carbon. Then this will be attached. You can see 1, 2, 3, and the fourth one making 4. Then also you can see 1, 2, 3, then the fourth one making 4. This is what we are talking about. This is the way we draw the structure. So now, another important thing we can look into is talking about the other type. So far, so good. I was able to brief the introduction of hydrocarbon into compounds containing carbon and hydrogen. I haven't said that. I said they can be aliphatic and they can be aromatic. So aliphatic, I group them into 3. I said they are the one you know examples. I gave you the alkanes. I gave you the alkanes and also the alkanes. So I said alkane and alkanes can exist as what? Cyclo, then by alkanes, you can't say cyclo. So we now say this particular category of aliphatic hydrocarbon can also be saturated and can also be what? Unsaturated. We talk about saturated compounds with these simple characteristics, and unsaturated compounds examples are those ones which are they exist in form of double and triple bonds, which we have talked under the group of what? Classification. So my short note I can just give you here for understanding's sake is just 1. You can have aliphatic hydrocarbon can exist in 3 forms. And if they exist in 3 forms, they can now be saturated and they can also be unsaturated. A very good example of saturated is the alkane, which is also an example of aliphatic. So whereby unsaturated, which we want to discuss, the example of the other 2 we talked about alkanes and the what? And the alkynes. So you just need to keep it in mind. Like I said, alkane can also be in cycloform. That is one we call cycloalkanes. So the elementary introduction is very important. So some characteristics of unsaturated hydrocarbon. The first is they have multiple bonds, like I've said here, which is very correct. They can be double and they can be single. Very good examples are, you can see, alkanes, cycloalkanes, alkynes, and aromatic. Remember, we also talk about this aromatic hydrocarbon in classification. We said they contain at least 1 benzene ring. It can be more than 1, so it can be more, it can be equal to 1. So that is the definition of arrow. So aromatic hydrocarbon is also an example of unsaturated hydrocarbon. So you need to keep this because it's very important to have that at the back of your mind. And again, another characteristic is the best definition we give to them is the possessor or possesses fewer than the maximum number of hydrogen atoms. As we know, you can see this is a very good structure. This is a carbon. This is a carbon. Now here, double bond is what is present here. As you can see, because of that, we know that carbon should contain 4. In this case, though the tetravalency is still going to be complete, but here the hydrogen attached here and the hydrogen attached here is just 2. So but if you can't with the double bond, you can see 1, 2, 3, 4. So but the carbon atom possesses what? 0 hydrogen atom compared to the saturated hydrocarbon. I hope you understand this, and this is the 3D structure which we're able to get what we're talking about. In continuation to what we're talking about, I will look extensively into alkanes, which is a very good example of saturated hydrocarbons. And about this, my dear student, alkanes, generally, they have the following properties. Alkanes are known as saturated hydrocarbon, which contain only a single bond satisfied. We've talked about that. The general formula for straight chain of alkane is CnH2 and 2. Very important for you to keep this at the back of your mind. Where N is greater than or equals to 1. So generally, you can do your kind of simple substitution. So I will still talk about how we name them. And with N is 1, you guys know this will be C. You can say 1, you don't write that. H, 2 times 1 is 2 plus 2 is 4. That is the first member. Then you continue. The second member will be C. When N is 2, 2 times 2 is 4. 4 plus 2 is 6. 2H6 will be the second member, which we are still going to talk about their names. So in continuation to that, now the general formula for cycloalkanes is CnH2. And now students need to be careful with this. Why I said to be careful with this is these look more or less, for those of you who have done the elementary course in your school, this look like the formula of what? General formula of alkanes. But here we are saying for cycloalkanes. So you just need to be careful. Cyclo. Or for example, when N is greater than, so this is only when N is greater than or equals to 3. I'll give you an instance. Let's take when N is 3. For us to understand this, we can say when we substitute 3 here, we have 2, that is C, 3. 2 3s are 6, 8, 6. So you are drawing a ring structure of 3, which will definitely be something like a triangle. So you can put your C, it is single bond, C, diagram of on to scale, and you satisfy each of them, as you can see. So it works. So it doesn't work for situation where N is what? Less than what? Less than 3. It is always greater than or equals to 3. So we can satisfy the hydrogen on what we thought. So this will be, this is 2. This is 2. And this is 2, which we are still going to talk extensively on. Like I said, you know why these are 2, 2, 2. And if you don't know, because we talked about the hydrogen in each of the what alkane, it's most what carbon is tetravalent. So that is what we are talking about. So let's move on. So when you complete it, you can say 2, 4, and 6. And this is what we call cycloalkane. And this one, you call this one. When we get to the naming, you understand. Whenever you want to name this structure, there will be a cycle in front. So I hope students understand that. That is what we are talking about. So next is the next point is we talked extensively on the members of the family. I'm talking about that. We say each carbon atom in alkane is 1 point sp3 hybridized. Another one is tetrahedral with 4 sigma bond formed by 4 sp3 hybrid orbitals. Good example is you can see carbon then is attached to this. So the center atom say X, P, and 3. So this is what we're talking about here. Center atom. We've talked about hybridization under inorganic chemistry, how we can calculate the hybridization of both organic compounds and inorganic compounds. So it is very easy to use that knowledge of our lone pair and bond pair to always get this, which we've talked about. Even it tells us the shape. We know if it is sp3 hybridized, definitely it's going to be what? Tetrahedral or tetrahedral, the way you call it. If it is sp2 hybridized, it should be triagonal. It can be in 2 cases. It can be a triagonal pyramidal, it can be triagonal planar, it can be triagonal bipyramidal, which we've talked about sp2, sp3, sp3d, and so on and so forth. I only want to focus on what we have here. That is the essence of giving you guys in slide understanding. So alkanes are sp3 hybridized. They have a tetrahedral shape, and the meaning of tetrahedral shape we've talked extensively on that also before. which you are going to be seeing in 3D. So never mind. Now the next thing is the bond angle. I've also talked about this before. Other key facts. The bond angle is at 109.5 degrees. So Alkane's IUPAC, which is International Union of Pure and Applied Chemistry names, have the same AN suffix. So whenever you want to write their member, ANE is going to be what you are going to use to end them. So and because of that, you can quickly look into the first 10 member. The first member, you can see ME methane when the carbon atom is 1. The next is when it is 2. You can see it is called X. And when it is 3, we call it prop. And look at the structure CH4. The second one, you can see it's CH3 plus this bond, make it tetrahedral. Carbon must be always before. So then this is the way we write it. Yes, you need to focus more on the structure. Now when it comes to this, you can see CH3, CH2, CH3, 3 carbons, 1, 2, and 3. Satisfied. And when it is for watch something, right? CH3, you can see CH2 twice. What it means is another person can write CH3, then you write CH2, CH2, then CH3. So you can write like this. This is the pattern they will continue to follow because they are single bonded. We've talked about that. So if I write it as CH3 all twice here, we're just using a kind of mathematical term, which I believe should not be difficult for us to understand. And the next one, as you can see, the same thing, the same process, you can see just from the standing state. That is why I love this pattern. So it's very easy to understand that, okay, the CH2 will continue in that manner. So we move like that. 6 is called hexane, and use a knowledge of polygons. Then 7 is heptane, and it will be 5 of the CH2. 8 will be octane, and which is also very correct. So 9 will be nonane, and 10 is decane. So it doesn't stop at 10. We still have other members, but we only want to focus on the first 10 member according to this syllabus for now. So when we need to focus more on others, we have a lot of other examples. They can be 20 carbon, call that UCAS, and so on and so forth. So let's just focus on what is needed. So now the next thing now is just to see the structure in 3D, like I said. And in 3D, the center atom is carbon, whereby others are hydrogen. You can see CC, and this is the way we draw a thing. So you can see these are the H. You can see C, so CH3, CH3, and you can see C, and the structure in 3D looks exactly like this. CC, you see, CC. Then some of you might wonder that why don't you draw it in a straight line? Yes, you can also make it straight. Like these are 4 C's. You are correct. Then satisfy what you talk about. This should be 1, 2, 3. 1, 2, CH2, CH2, then CH3, just like what we talked about in the previous slide of butane. As you can see, there are twice of CH2. So if you follow this pattern, all these are H. Carbon is always satisfying hydrogen, and that is why it is called hydrocarbon. So this is just exactly what we're talking about, which is also the same thing as this structure. So if you are drawing CC, and you are drawing the other on top, doesn't stop it. This is the way we visualize this in 3D. So look at this now. Pentanes are 5. You can see the way it is being drawn. This is 1, 2, 3, 4, 5. So it is just the visualization in 3D. But the normal diagram you are familiar with, which is this, is also very correct. Doesn't change anything. This and this will be CH3 the first and the last, whereby the one at the middle will always be CH2, CH2, CH2. So this is the way I want you to visualize, and this is the concept you need to know before we delve into the topic properly, introduction aspects as we have discussed. So you need to be careful about understanding, and from now on, we are going to talk more on Alkane. And another important note is for you to note this. Starting from butane onwards, the Alkane shows a phenomenon of chain isomerism. So we are still going to talk extensively on this topic called isomerism. So, and what is isomerism? For just fundamental knowledge, it's just one of the properties of organic compound in which they have the same molecular formula, same, but structural formula is different. That is what we call same molecular formula, but different structural formula. So when you watch Alkane from alkanes generally from the number 4 family, we notice that we can actually draw them in different form. So, and the very good example I'm going to show you very soon. So they can actually exist as a linear or as branch, just like what I explained before in the previous slide. Now, a very good example is this. Now look at this now, C4H10, which we know to be butane. So we want to do that. This is the 3D shape I'm talking about, which I can also redraw in this format, which is another thing. Now, these are the two different structures. If you watch this, for you to see very clearly, the first carbon atom here is attached to 3 of hydrogen atom. So we have CH3. I just want you guys to follow. That is CH3. And in between here, we have the CH2, which is always, you can see the carbon is always the one in my color stuff. I don't know, it's this ash or whatever color you call it. So you can see this is the H and the H, and this is the H and the H. So we have CH2 twice. Then we have the carbon is there, and we have the H, we have the H, and we have the H. Isn't this very funny? So this is the first one. So which you draw structurally like C, there are 4 carbons, C and C. Let me make it linear. So you have 1, 2, 3, which means H, then this 1, 2, 3. So which is CH3, you can say CH3, 3 H's. Then this is CH2. This is another CH2. So which composed together, which was formed together to be CH2 twice. And this is CH3. So this is the first structure, which is what we call, this structure is called normal butane, which we write as N-butane. Now, the other structure now, which can also exist like this, which we call isobutane. You can see now, I told you the carbon is always the one. So these are the one, H, as CH3. Then you have the carbon, you can see this. You have the carbon here, you have the carbon here, you have the carbon here. So we just need to be careful. Here we have C, we have 1 H just attached to this C. For here we have 3 H's, 1, 2, 3. And here we also have 3 H's, 1, 2, 3. So CH3 is appearing here twice towards the end. At the middle, we have only C and H. Now, if you want to understand this very well, what we call this chain isomerism, and say they have the same general formula, but their structure in 3D appear different or differently. Now, a very good example is what you can see here, because if you count the total number of carbons here, this is 1 carbon, and this is 2 outside. You need to go to be good in what? Each of arithmetic. So this is 2 carbons. 2 plus 1s are 3, plus 1s are 4. This is C4. That's the H. 3 H's. 2 times 2 are 4. 3 plus 4, 7 H's plus 3, 10. Satisfied. C4H10. And here as well. 1 carbon, 2 carbon, then the outside carbons are 2. That is 4 carbons. Then hydrogen here is 3 plus 1 is 4. 3 times 2 are 6. 4 plus 6 are 10. Also satisfied. So both of them here are called what? Chain isomers. Now, what do we call normal? What do we call iso? For you to understand, which we are still going to talk extensively, when we say isobutane, what we are trying to say is that what? On the second carbon atom, let me draw it structurally, linearly, the one we are familiar with. Now, it will be like this, say 1, 2, 3, 4. Then on the second carbon atom, which we are still going to talk about the naming, we have the CH3. That is what we're talking about. Now, others will now satisfy H, H, CH3. Here you have, you can see, this is what we're talking about. This is C. We have, oh, sorry about that. I have made a mistake. So I've extended my carbon should be here. And that's, will make me redraw. So I'm drawing butane 1, 2, 3. Then the fourth carbon, I'm putting it directly under here, which is kind of simple now. So you can complete it by putting the hydrogen, and just the way you know it, for you to be able to understand better. Hydrogen, and this is a hydrogen here, and this is you can see this is one hydrogen, then it's needed 3 hydrogen to satisfy. So you got this one will be right as CH3 plus 1. So my point here is just a very simple point, like when the methyl group is placed directly at the second carbon atom, such we call an isobutane or iso of that particular compound. When it is drawn directly in its normal structure, we call it normal or end of that particular name of the family. Like I said, you don't need to worry yourself too much because we are just getting started. So basically, when compound exhibits this type of situation whereby they have the same general formula, but the way we represent their structure, especially in alkane structure, starting from the 4th carbon atom and above, such type of isomerism is called chain isomer. It is not only this. So it is just like, okay, instead of me drawing 4 carbons, I'm now drawing 3 carbon, I'm now positioning the 4th carbon as any of the position I want to place it. But it is always advisable in this type of 3 cases, you only put it in the middle. Because if you put it here, you will see that it is still drawing the same structure as what you've drawn before. So my point here is that when this kind of situation exists, then you have actually reorganized the position, the arrangement, but you have not touched the total number of carbon and hydrogen, and this is called chain isomerism in alkane. So we are still going to talk more about it. It's not only C4H10 that can do that. In fact, if you have more than 4 carbon atoms, except from 4 and above, it is possible. So, and you can draw them in different groups. So understanding it, we first of all need to understand how to name them. Then when you know how to name them, then you will understand the details of how to form the isomer, because it is just procedure. So next will be another example is in case of this, I love this straight chain, which we have you see. You can see the normal pentane, which is 5 carbon, and the hydrogen. But if I have this, look at this here. In the second one here, which is very good, I am putting my carbon here, the 5th carbon under the second carbon. So now in this case, I will now name this. This is 1, 2, 3, 4. So 4 carbon is, as the parent now, is butane. So because on the second carbon, I am naming this thing. On the second carbon, I'm putting my CH3, which we call methyl. All these are called substituents, which we are still going to talk more in the later part. So now my point here is that at this point in time, it is on the second one. So I'll call that 2-methyl, then the parent name butane. Don't worry yourself too much now for how to name all this stuff, because we are going to do that as a whole topic in the next class, which will be tomorrow. So now another thought, but you can also put this carbon atom on the what? On the 3rd one, or reduce this one to 3 and put the remaining 2 in other way. Look at it. Another example is possible. Can you see? And instead of drawing 5, you can see I drew 3. 1, 2, 3. And after drawing 3, I put one of my the 4th carbon atom on the second carbon. I also put the 5th carbon on the second atom. So I have 1, 2, 3 is the parent name, which is the propane. Then on the second atom, I have methyl, the CH3. I also have methyl. When you have two of methyl, it is called dimethyl. And you have to write the number. It is on the second carbon atom, the first methyl was, that is 2-methyl, another 2-methyl. So you now write it together as 2 of dimethyl. So my point here is very simple. If you still got the number of carbon and hydrogen, it will still satisfy C5H12. So whenever it satisfies C5H12, or they have the same general formula, or the way you are giving your structures are different, such type of situation we call isomers. So in this case, we call it chain. Again, it is called chain isomerase. So let's keep that in mind. It is very important, and that is where I will stop this particular lesson. In the next lesson, we are going to talk extensively on how to give name to alkane. So in these lessons, we've talked about introduction to alkanes. And apart from introduction to alkane, we group alkanes by hydrocarbon generally into aliphatic and aromatic. So we say aliphatic can be alkanes, and alkynes. And alkane can also exist as cyclo. And we also talk about aromatic hydrocarbon as those one that has at least one benzene in them. So we also talk about examples of aliphatic and aromatic hydrocarbon in terms of saturated and unsaturated. And under that, we're able to talk about a very good example of saturated is the alkane and the cycloalkane. So they are saturated because of some properties of a single bond. Another property we talk about is that because there exists apart from the single bond, the hydrogen satisfy what the carbon. So the tetravalence of carbon is being met. And again, because of that, alkane has a property of sp3 hybridization. And we talk about generally they have a formula of CnH2n plus 2. By cycloalkane as a general formula of CnH2n. The condition is when n is greater than or equals to 10. That is when this formula holds for cyclo. So we talked extensively on another properties apart from this. As the first 10 members to be about how to draw the structure, it's just focusing on what on the carbon. And another special property we talked about is the isomerism or the chain isomers, which exists when the general formula are equal or same, but the structure not the same. So, and that introduces us to a substituent of methyl, which is CH3, which can be positioned at different points. And this only exists in alkane when the carbon atom is greater than what? The number of what? The number of carbon atoms is greater than 3. So we talked about that also, and we said it is just in the introduction to the topic of hydrocarbons. We have a long way to go. In next class, we are going to talk about hydrocarbon nomenclature, so students can read ahead of it, and, so that it will make us touch all necessary areas in the fastest possible. So see you guys soon. Have a wonderful time. Stay blessed. Bye.